Introduction. So I hope everyone know a line. If I create a line, I have to give the labeling for that line, either AB, because line has 2 points, minimum 2 points a line has. So starting point is A, ending point is B. They can give anything in the problem. They can ask PQ, draw a PQ line, they will ask. So the starting point of line will be letter P, and the ending point of the letter will be become Q. Okay, so A, B, P, Q, they'll give anything in the exam. Okay, so a line is nothing but when you join 2 points, a line is created, and the line can be anything. Line can be horizontal, line can be vertical, line can be inclined. Anything can be possible in the lines. Okay, so whenever I say line, don't think that it is a horizontal line. It can be anything. It can be horizontal line, it can be a vertical line, and it can be a inclined line also. Depend upon. Okay. So for everything you have to give the labeling A, B, P, Q, or any other words what are given in the problem. You have to use those words. Okay. And for a line, it will be capital letters. And if a line is projected on the, okay, so I'll be again drawing. So this is my horizontal plane and vertical plane. So this is my vertical plane, and this is my horizontal plane. Okay. This is my horizontal plane. Suppose my line is in the top view. Suppose my line is the top view, then I have to write AB line. So then I have to write small letter AB. Okay. Suppose if on my vertical plane, my line is vertical. So this is my front view. So I have to write P dash and Q dash, small letter P dash, small letter Q dash. Okay. Suppose this is my side view, which is nothing but the profile plane. This is the profile plane. So for the profile plane, if a line is inclined, example, suppose I have to write this as small letter A double dash and B double dash, because on the HP plane you will be getting the top view. Top view you have to write small letters. On the vertical plane you will be getting the front view. You have to write P dash and Q dash, small letter and dash you have to write. On the profile plane you have to write it as small letter double dash, small letter double dash. For the 2 points you have to write. Okay, that is the main thing you have to understand. If you're not giving this labeling A double dash or B double dash for the profile plane, A or B on the horizontal plane, P dash and Q dash, example like P dash and Q dash, if you're not giving, marks will be reduced. And there are some inclination angles. If I want to make an inclination, there will be certain angles such as theta, alpha, beta, gamma. Those angles you need to understand. Why those angles are there, you need to understand before starting the projection of straight lines. And I also told you to write the theory part. Compulsory write the theory part. If you write the theory part once, then only you will be understanding. Okay. Yeah. A straight line is defined as the shortest distance between 2 points. Suppose I have 2 points. If I join these 2 points, it will become a line. That is this one. And this is a one dimensional. It has only one dimension, either length or width or thickness. Okay. When it has length, it doesn't have any thickness. Whenever we say a line, it has no thickness. It has only the length value. Straight lines are drawn by joining two respective projection of endpoints. So initially you need to have two endpoints, endpoint A and endpoint B, or endpoint P or endpoint Q. If you join those endpoints, then you will be getting a line. Okay. And line may be different orientation. It can be parallel. Okay. It can be, suppose this is my horizontal plane. Okay. So wait, I'll be drawing again. So this is my vertical plane and this is my horizontal plane. Okay. So it may be parallel to the plane. So this is my plane. This is my vertical plane. It can be parallel to the plane. It is parallel, but this line and this line are same parallel, or else it can be perpendicular to the plane. So with respect to vertical plane, this is my perpendicular because this is my horizontal plane and this is vertical. So it is vertical to the vertical plane. And with respect to horizontal plane, this is parallel to horizontal plane and this is perpendicular to horizontal plane. And with respect to the profile plane, this is parallel to profile plane and this is perpendicular to profile plane. Okay, or else it can be inclined, such a way that this is parallel. For the parallel, I am taking at an angle. So this is the inclined to the profile, inclined to the vertical plane. So already this is my horizontal plane, which is parallel to the horizontal plane. If I take an angle, it is inclined to this horizontal plane. So already this is my parallel to profile plane. If I take any angle, this is the inclination to the profile plane. Okay, so anything can be possible. The orientation can be parallel, perpendicular, or inclined to one plane or both the planes. Okay, so these things you have to remember. Line can be horizontal, perpendicular, or inclined to any of the planes. Okay, I will show you how those are inclination. Okay, so everyone watch the video. I am stopping the share. So everyone watch the video. Yeah. So watch my video carefully. So this is my horizontal, this is my vertical plane, this is my horizontal plane, and this is your profile plane. Your profile plane will be like this. You can't see anything, only the line you can see on the profile. This is your profile plane, this is your vertical plane, and this is your horizontal plane. So whenever I say the vertical plane, so suppose this is a line, AB. Starting point is A, ending point is B, line AB. Then this is my vertical plane. Whenever I say parallel to vertical plane, it is like this. This line and this line are parallel to each other. So this is my parallel to vertical plane, and with respect to this line and this line, it is parallel to vertical plane. So two cases are possible whenever I say parallel. Either this is parallel to vertical plane or this is parallel to vertical plane. And whenever I say perpendicular, this is my perpendicular to vertical plane because it is 90 degrees to the plane. This is my perpendicular, this is my parallel to vertical plane, this is my parallel to vertical plane, and this is perpendicular to vertical plane. And whenever I say inclination to vertical plane, it can be anything. This is my parallel, then I am lifting like this. Whenever I am lifting like this, my pen, this is the inclination at an angle. So this is my angle, inclination. Now line is inclined to vertical plane. Similarly, this is my parallel to vertical plane. Whenever I say inclination, it can be like this. Whenever I am giving an angle, already it is 0 degrees. Now I am giving 10, 20, 30, 40, 50, 60, 70, 80, 90. 90 is perpendicular. Okay. So this is my 0 degrees line. Now I am giving 10, 20, 30, 40, 50, 60, 90. 90 is my perpendicular. So whenever I say perpendicular, this parallel is rotating 90 degrees and this parallel is rotating 90 degrees. So both are 90 degrees to this vertical plane. Okay. Similarly, coming to horizontal plane, this is my horizontal plane. And if I place my line like this, then it is parallel to each other. It is parallel to this side. It is parallel, or it is parallel like this. Okay. And whenever I say perpendicular, it has to rotate 90 degrees. So this is my 0 degrees line. It has to rotate 10, 20, 30, 40, 50, 60, 90. So this is my perpendicular to horizontal plane. Suppose this is my parallel, then I have to rotate this as 10, 20, 30, 40, 60, 90. So this is my perpendicular. So whenever I say this is 90 and this is 90. So parallel can be two cases. This is also parallel to horizontal plane. This is also parallel to horizontal plane. Okay. And this is 90 degrees. This is exactly 90 degrees. It can be, you are rotating this to 90 degrees. I am rotating this to 90 degrees. So both are 90 degrees to horizontal plane. And similarly, this is your profile plane. So whenever I say profile plane, this is parallel to profile plane and this is also parallel to profile plane. Okay, this is parallel to profile plane and this is also parallel to profile plane. And what happens is, if I want to make this line perpendicular, then I have to take 10, 20, 30, 60, 90. Then I'm making this is parallel to my profile plane. And if you see this case, this is my 10, 20, 30, 40, 50, 60, 90. And this is parallel. This is perpendicular to profile plane. Okay. So this is perpendicular to profile plane and this is also perpendicular to profile plane. Okay. So those things you have to understand. Okay. I'll explain in this also. So if you see this one, this is your horizontal plane and vertical plane. This is your horizontal plane and vertical plane. This is my horizontal plane and this is my vertical plane. Okay. So whenever I say parallel, if there are two cases, either my line can be like this or like this. Both are parallel to HP. This case is parallel to HP and this case is parallel to HP. And whenever I'm making perpendicular, to horizontal plane, it is automatically parallel to vertical plane. Whenever I'm making perpendicular to horizontal plane, it is automatically parallel to vertical plane. Okay. So this is parallel. So whenever I'm making parallel to vertical plane, it will be perpendicular to horizontal plane, because these both angles are 90 degrees, because the vertical plane and horizontal plane are both at an angle of 90 degrees. Whenever I'm making parallel to vertical plane, it is automatically perpendicular to horizontal plane, and whenever I'm making parallel to horizontal plane, it is automatically making perpendicular to vertical plane. So in cases, some cases, what happens is, whenever a line is parallel to horizontal plane, it is automatically perpendicular to vertical plane, and whenever a line is parallel to vertical plane, it is automatically perpendicular to horizontal plane. Okay, the theory part. Okay. So there are few terms which we use in the projection of straight lines. So the first term, true length. So true length is nothing but, true is nothing but your actual. True is nothing but actual. Length is nothing but your distance of the line. Okay. True is nothing but the actual length of a line, known as true length. So sometimes what happens is, it depends on perspective. Suppose this is my vertical line. If anything is parallel to each other, suppose this is my vertical line, suppose this is my vertical plane. On the vertical plane, I am drawing exactly 90 degrees. Okay, I am drawing exactly 90 degrees, so I can see the true length. True length is projected here, and this is my parallel. Then I can see, suppose my line is somewhere here, then I can see my actual length here. But sometimes what happens is, whenever I make an line inclination, you can't see the true length.
Yes.
Yeah, whenever I can make the line as an inclination, you can't see the true length. The line will be reduced. So either the length of the line should be true length or less than true length. It will be true length, or it will be less than true length, or equal to true length whenever a line is projected. Okay, those things you have to understand. True length is nothing but what are the actual length of a line. Because suppose my pen distance is about 100 mm. Example, my pen distance is 100 mm. This is called true length. Whatever angle I rotate, whether it can be horizontal, perpendicular, inclination, any inclination, the true length will be same. But when I'm making the projection, the length will be reduced. It won't be increased, it will be reduced. Either it will be reduced or it will be show the true length, whatever the projections you are making. Okay. Next, plan. So when we are discussing the projection of points, I told that top view is also called as plan. So in the problem, they'll ask, show the plan length. So in the exam, they show the plan length. Plan length is nothing but the top view length. And when I am discussing projection of points, I told that elevation length. This elevation length is called as the front view. This elevation length is called as the front view. Okay. So listen carefully. So in the exam, in the problem, if they ask the plan length, it is nothing but the top view length. You have to understand. Okay. It is the apparent length of a line seen in the top view. So whenever you are seeing a line in the top view, that is called as the plan length. Okay. So whatever may be the line, if you are seeing on the top view. So top view you can see on the HP plane. On the HP plane, you can see the top view. Whenever you are seeing any line, this is called plan length. We have to represent this as PL. PL is nothing but the plan length. So whenever you write PL, I will understand that it is a top view length. Okay. So here don't write top view length, you will writing it as PL. PL is nothing but the plan length or top view projection of the line. And whenever you will be writing, whenever you are writing EL, EL is nothing but the elevation length. It means that you are representing the front view length. Front view length, whenever you are representing front view length, you have to write it as EL. And whenever you are projecting the top view length, you have to write it as plan length. Okay. Yeah. So apparent length seen in the top view. Okay. So this is my book, which is a horizontal plane. So whatever I'm seeing, so look here. So I'm stopping the share. So once look here. So I told that it is a plan length. So plan length is nothing but this one. So if you see on the top view, you can't see the complete length. Can you see? Yeah, whenever you are seeing the top view, this is your top view, and this is your actual length of the pen. Suppose the pen length is 100 mm. So this is actual length. But when you're seeing the top view, you can see only a dot. You can see only a dot. This is only 0 to 1 mm will be there in between 0 to 1 mm. So this is your top view. So top view will be just a point. This is not true length. You are not seeing the true length of the top view length. Top view length will be 0 to 1 mm, but actual length of the pen is 100 mm. Okay, that is the difference. You are saying the top view length or plan length. Okay, so I'm sharing the screen. So that's the reason what happens is. If a line is parallel to HP, plan length is equal to true length. Plan length equal to true length, because this is my parallel. So this is my HP and this is parallel. Whenever it is parallel, I can see the complete length. on the horizontal plane. And whenever it is any inclination other than any inclination is 90 degrees inclination. So it is perpendicular. So whenever it is perpendicular, or if I given any angle such as 0 degrees, 1 degree, 2 degree, 3 degree, then the true length will reduce. So this is my true length on this one, 100 mm. If I rotate, suppose 10 degrees, the 10 mm is reduced. If I rotate 60 degrees, 60 mm is reduced. If I rotate 90 degrees, it will become 0. And again, if I am rotating 100, 110, 120, again it will increase. Whenever I am keeping 90, it will become 0. And again 110, it will increase. And you can, whenever it is again rotated from this side to this side, if you rotate it, you can see the complete true length of the pen. Okay. So whenever a line is inclined, whenever I'm making an inclination to HP, then plan length is less than true length. True length is 100 mm. The plan length will be reduced, less than it will be. Okay. So we can say that true length can be either less than or equal to true length. Okay. The plan length will be less than or equal to true length. Whenever we given any inclination, 1 degree, 10 degrees, 20 degrees, 30, 60, 90, whenever we are giving inclination, the length will reduce. Okay, maximum length is true length. Either the plan length will be equal to true length if it is parallel to HP, or it will, whenever it is inclined, it is plan length is less than true length. Okay. And next one, elevation length. Elevation length is nothing but the front view length. It is apparent length of a line of a front view. So whenever I'm seeing a line in the front view, so this is my vertical plane. Whenever I'm seeing any line in the front view, this is my elevation length. Whatever the line I am seeing, this is my elevation length. And same principle is applied here. If a line is parallel to vertical plane, whenever a line is parallel to vertical plane, then elevation length equal to true length. Whenever the line is parallel to VP, then elevation length equal to true length. And whenever a line is inclined to VP, then elevation length is less than true length. Therefore, I can say that elevation length is either less than or equal to true length. either less than or equal to true length. Okay. Whenever line is parallel to HP, then plan length equal to true length. Whenever line is parallel to VP, elevation length equal to true length. And whenever line is inclined, any inclination, whether 0 degrees to 1 degree to 89 degrees, whenever there is inclination, plan length is less than true length. Similarly, elevation length is less than true length if there is any, if the line is inclined to VP. Okay. Yeah. Yeah, I will take the attendance. Everyone raise your hands. Anyone not raising the hand will be marked as absent. I will give only 30 seconds to raise your hands. Within 30 seconds, you have to raise your hands. Yeah, only 24 members raised. 25. Anyone not raising the hand will be marked as absent. And this is important topic. You have to listen. If you are not listening, it is difficult to pass this drawing subject. Yeah, still roll number 7, 11, 17, 22, 26, 27, 32, 33, 34, 36, 49, 51, 59, 16. If you are not raising your hands, will be marked as absent. Yeah. I am lowering all the hands. Attendance completed. Again, I'll ask to raise at the end of the class. At that time, if you're not raising, you'll be marked as absent. Okay. Yeah, any doubts, you can unmute and you can ask. If anyone any doubts, you can unmute and you can ask. Whenever I give inclination, the length will be reduced. If I give any small inclination, the length will be reduced. Yeah. Any doubts, you can unmute and you can ask. If anyone has any doubts, you can unmute and you can ask. If no doubts, I'll start the next topic. So understand only one thing, that whenever line is parallel to HP, plan length equal true length. Whenever a line is parallel to VP, elevation length equal true length. Whenever a line is inclined to HP, plan length is less than true length. Whenever a line is inclined to VP, elevation length is less than true length. And similarly to the profile plane. And similarly to the profile plane. And similar to the profile plane, we call it as side view length. For the profile plane, we call it as side view length. And whenever a line is parallel to profile plane, whenever any line is parallel to profile plane, then side view length equal to true length. And whenever a line is inclined to profile plane, side view length is less than true length. Therefore, I can say that side view length is either equal to true length or less than true length, less than or equal to true length. Okay. So everyone watch this video once so that you will be understanding. I will be showing the video after the inclination with HP. Okay. Suppose this is my line, which is 0 degrees to HP. Okay. This is my letter A and letter B for the line example. Now what I'm doing is I'm giving some inclination. So this is my radius. Radius is, suppose example 50 mm. Example radius 50 mm. So now I'm giving inclination. So suppose I'm giving an inclination of 30 degrees. Listen carefully. Now I'm giving a inclination of 30 degrees. So what I do, I'll keep a protractor. First I'll mark a 30 degrees line. 30 degrees line I'll mark. Then I'll draw a 50 mm. Okay. And I'll mark this as somewhere as B dash. Example, I'll mark this as B dash, because same letters I shouldn't be repeating. If I give letter B, I shouldn't give letter B, same thing. So this is a B only, so I'll be giving as B dash. Example. So this is 50 only and this is 50 only, but the angle inclination is 30 degrees. Okay. So what I can do is, instead of giving this as 50, what I do is I'll take a compass. I'll draw an angle of, I'll draw a radius. So I'll take a compass, keep my compass pointer here, and I'll keep my pencil here, and I will draw the arc. And where this arc is touching this 50, then that is the point. Okay, what I do is I'll take a protractor and I'll mark a 30 degrees line. So this is my horizontal line. I'll draw a 30 degrees line. So I don't measure with the scale. What I do is, this is my letter A. So what I do is I take a compass, I'll draw the arc. Wherever this arc is touching, this same 50 mm is transferred 50 mm this side, because this is a radius. For the radius, the distance is same. Okay. And I'll mark this point somewhere. Okay. So what happens here is, whenever a true line makes an inclination projection. So if you see here, everyone look here. This is my letter AB. This is my letter AB. True length. True length is 50. Okay. And this is my top view. I'm seeing from the top. I'm seeing from the top view. And now I've taken an inclination of 30 degrees. Example, the theta is 30. If the theta is 30, then I am making an inclination of 30 degrees. And what I do is, I take a compass and I make a rotation. And I'll extend this one, so that this is the intersection. I'll draw the horizontal line at this point. So this is my true length 50 mm. But if I'm seeing from the front view, I can see only this line. I can see only this line. From here to here, I can see. Suppose this distance is 45. So this is when I'm seeing from the top view, whenever I'm making any inclination, theta, suppose I'm making the angle theta equal 30 degrees, then what happens is it will reduce the length. That is called, already I explained in the previous slide. So this is my plan length, top view. I'm seeing from the top view. So whenever I'm seeing the top view, the length will be reduced. Actual length is 50 mm, but when I'm rotating, this distance is true length. This is true length 50. This is true length 50, but when I'm rotating, I am seeing from the top view, this is my reduced length. So this 5 mm length is reduced when I'm seeing from the top view, because I gave the inclination. Okay, that is the same thing. So whenever it is measured along plane containing the line perpendicular to HP, it is indicated by theta. So whenever there is any angle, inclination with respect to horizontal plane, you have to give it as theta. Okay. So this is my true length. This is my true length PQ. So listen carefully. This is my true length PQ. Now what I am doing is, I am taking an angle theta, I am extending angle 30 degrees. And then what I do is, I take this as a compass and I'll draw the arc. And wherever this arc is touching, I have to draw the vertical line, because this is my top view. This is my top view. I'm drawing the vertical line. And this is P and Q1. Because in the top view, I need to project as small letters. And in the front view, I have to project it as, small letter with the dash. And same this line, I'm projecting in the front view. It will project as P dash. Same Q1 line, I'm projecting in the front view, it will become as Q1 dash. Okay, because this is Q, capital letter Q. After rotating, it will become as capital letter Q1. This capital letter Q1, I'm projecting it as Q1 dash. Okay, this Q will project it as Q dash. Okay, so watch the video once, you will be understanding. So how I to project is, this Q1 dash I'm projecting down here. This is actual length, true length, and this length is the plan letter Q1. Okay, so here what you have to write is, plan length is less than true length, and here you have to write that elevation length equal to true length. Elevation is nothing but the front view. Front view equal to true length, and plan length is less than true length. You have to write. Okay, so I hope everyone understand. Watch this video once.
Line inclined to one plane and parallel to the other. The inclination of a line to a plane is the angle which the line makes with its projection on that plane. Line PQ1 is inclined at an angle theta to the HP and is parallel to the VP. The inclination is shown by the angle theta which PQ1 makes with its own projection on the HP, that is the top view PQ1. The projections may be drawn by first assuming the line to be parallel to both the HP and the VP. Its front view P dash Q dash and the top view PQ will both be parallel to XY and equal to the true length. When the line is turned about the end P to the position PQ1 so that it makes the angle theta with the HP while remaining parallel to the VP. In the front view, the point Q dash will move along an arc drawn with P dash as center and P dash Q dash as the radius to a point Q dash 1 so that P dash Q dash 1 makes an angle theta with XY. In the top view, Q will move towards P along PQ to a point Q1 on the projector through Q dash 1. P dash Q dash 1 and PQ1 are the front view and the top view respectively of the line PQ1.
Okay. So any doubts? So I'll share this video once again, and anyone who is having any but CD, when they bought the textbook, they give the CD. In that CD, you can see the module 23, line inclined to one plane and parallel to other, you can see. Okay. And okay. So that is the inclination concept. So whenever I make a line inclined, so inclined in the view, in when I give the inclination theta, which is above XY line, then it will become the plan length is less than true length. Plan length is less than true length. Whenever I give the inclination theta, plan length is less than true length. And whenever I give the inclination, which is phi, whenever I give the inclination, which is phi, then elevation length is less than true length. Okay, so these things you have to understand. So this is a concept. This is the inclination with HP. So there's another concept. I'm giving inclination to VP. So if you see that this is my VP. So for that VP, this is my RS line. So this is my RS line, which is true length. RS line, which is true length. Then for this RS line, I give a distance, D distance. I give a D distance. Then this is my RS line. This is my RS line. What happens for the RS line is I gave an inclination of phi. When this phi inclination is less than below XY line, whenever I give the inclination theta, which is inclination with HP, then it is above XY line. This is for the first quadrant. For the first quadrant, whenever I give the inclination theta, which is above XY line, and if I give the angle phi, which is less than below XY line. So here I gave the inclination. So what I have to do is, so this is my RS line, then I have to draw the arc. Draw the arc. This is my angle phi. Okay, so this is my angle phi. So this is my inclination with respect to VP. Okay, so I'll also show a video of inclination with respect to VP. Watch it once again. Okay, so VP is the inclination that which makes with respect to the vertical plane. Okay, so this is my vertical plane. So for this vertical plane, this is my horizontal line. This line is parallel to each other, parallel to vertical plane. Now what I do is I move my, give the angle. The angle is suppose 45 degrees. Okay, so this angle is called phi. So whenever I give inclination with the VP, it is called phi. And whenever I give inclination with respect to HP, this is called theta. Whenever I give inclination with respect to HP, it is called theta. Whenever I give inclination with respect to VP, it is called phi. You have to remember these things. Okay. And whenever I am projecting like this, so what happens here is, so see here, this is my XY line. Now I'm giving a projection here in phi. I'm giving my phi, and this is my horizontal line. For this horizontal line, I'm drawing an inclination like this. If I project this one, it will be same. Initially, it will be same. And because of this reduction in the length, this elevation length is less than true length. This elevation length is less than true length. Okay. So watch this video once. So this is my actual line RS. Capital R, capital S. So this is same RS. This is at a distance of D distance. And this RS is at a height of H distance. Then This R is projected in the front view as small letter R dash. This capital letter S is projected in the front view as S dash. Okay. And this capital letter S is projected in the top view as small letter S. This capital letter R is projected in the top view as small letter R. So you know these things. Now what happens is, here I gave the angle phi. So I gave the angle phi, such as example 45 degrees, I gave the angle phi. Then this is the same radius, I have to rotate. So it will meet at this point. From this point I'll mark it as capital letter S1. So this S1 projected in the front view as S1 dash. I will project this one in the front view. It will project it as S1 dash. If I project in the top view, it will become as S1. It will become as S1. Okay. So this is the thing you have to understand. Okay. So whenever I make the projection, this is my true length. So this is my true length. This true length, I made a radius. So it will be this plan length. Plan length is nothing but the top view length. Plan length is equal to true length here. And this is my elevation length. Final front view length. My elevation length is less than true length here, because this is my R dash and S dash line. R dash S dash line is the true length, but R dash and S1 dash is the elevation length, which is less than the true length. Okay. Yeah, watch this video once so that you will be understanding. Watch this video carefully. No, okay, wait. I'll be again playing the video. I think, yeah, wait. I'll be playing the video.
Line RS1 is inclined at an angle phi to the VP and it's parallel to the HP. The inclination is shown by the angle phi which RS1 makes with its projection on the VP. That is the front view R dash H dash 1. Assuming the line to be parallel to both the HP and the VP, its projections R dash, H dash and RS are drawn parallel to XY and equal to its true length. When the line is turned about its end R to the position RS1 so that it makes the angle phi with the VP while remaining parallel to the HP, in the top view, the point S will move along an arc drawn with R as center and RS as radius to a point S1 so that RS1 makes the angle phi with XY. In the front view, the point S dash will move towards R dash along the line R dash S dash to a point S dash 1 on the projector through S1. RS1 and R dash S dash 1 are the projections of the line RS1. Therefore, when the line is inclined to the HP and parallel to the VP, its top view is shorter than its true length, but parallel to XY. Its front view is equal to the true length and is inclined to XY at its true inclination with the HP. And when the line is inclined to the VP and parallel to the HP, its front view is shorter than its true length, but parallel to XY. Its top view is equal to its true length and is inclined to XY at its true inclination with the VP. Hence, when a line is inclined to one plane and parallel to the other, its projection on the plane to which it is inclined is a line shorter than its true length, but parallel to the reference line. Its projection on the plane to which it is parallel is a line equal to its true length and inclined to the reference line at its true inclination. In other words, the inclination of a line with the HP is seen in the front view and that with the VP is seen in the top view.
So here it is saying that, yeah. So whenever a line is inclined with respect to HP, then true length is seen on the front view and top view will be reduced, little bit reduced. And whenever inclination of line with VP, whenever there is an inclination on VP, then top view is a true length and front view is a lesser length compared to true length. Okay. Yeah, any doubts you can unmute and you can ask. This is the important topic. If you don't understand this topic, you don't understand the other topics of engineering drawing. Okay. Yeah. So next one. Yeah. So this is my profile plane. So any inclination with the profile plane. So any inclination with respect to the profile plane, this angle is called omega. Okay. So there is an inclination with the phi. Then this angle you will be considering this one. Okay. And it will be whenever this is this one, then the angle projected will be less than the, here it will be less than the, on the side view length it will be less than the true length. Okay. Yeah. So next is the apparent angle. So if you see that this is my XY line, this is my XY line. So whenever I give an inclination above XY line, it is called theta. And whenever I give my inclination below XY line, it is called phi. Okay. Then because of this inclination, if there is any effect, yeah, and this is my inclination theta. Theta is inclined with respect to HP and phi is inclined with respect to VP. And theta will be above XY line in the first quadrant and phi will be above XY line in the first quadrant. And next is nothing but the apparent angle. Next is nothing but the apparent angle. This is also important. So whenever already I have theta, I gave the angle theta here for this locus. So this is called locus. So for this locus already I gave the angle theta. And because of giving the angle phi, because of giving angle phi to the vertical plane, what happens is this will again project here. This will again project till here. And this angle, I need to draw one more angle. This angle is called alpha. So this alpha is also above XY line. So once again I'll explain. So listen carefully. Already this is my XY line. For this XY line, already I gave my angle theta. Angle theta. And this line will become as the locus. This line will become as locus. And already a line is straight. Again I am giving the angle phi. Again I am giving the angle phi, which is nothing but inclination to VP. Because of this inclination, again the line will lesser. It will project as lesser. And this is my projection in the front view. So again, if I join this to the starting point A dash, then this angle is nothing but the alpha. This is called apparent angle. It is the angle between the front view. Already I have this front view. Front view, this is my final front view. Front view is nothing but the elevation length. Front view or elevation length. This elevation length with respect to XY line, that is called my apparent angle. Okay. So whenever you see here, alpha is always greater than theta. You see that alpha is always greater than theta. It is an angle which an oblique line seems to be making HP with HP in front view. So with respect to front view, whatever the angle it is taking with respect to the front view, it is called that one. Okay. Yeah. So this is called apparent angle alpha. Okay. So already whatever I have said, same thing. So already I have my line AB. Already I have my line AB. So for this AB line, I gave my inclination theta. Already I gave my inclination theta. And for this theta, again I'm making one more inclination. One more inclination at the front. This inclination, again I'm making one more inclination at the front. And what again this inclination, if I'm projecting here, then this will become as B dash. Because I'm making one more inclination here. This inclination will project here, and if I project this inclination here, it will become, this is called alpha. Okay. So always alpha is greater than theta. Alpha is greater than theta because I gave one more inclination. That's the reason I need to project this line to locus of PQ. Okay. And there is one more angle called beta. So when the beta comes here is, so look here. So whenever I draw my XY line, so here I have drawn my XY line. So here I gave my angle theta. Here I gave my alpha. Here I gave my alpha. So what happens here is theta and alpha are given. Then because of this alpha, what I do is there's one more projection. I have rotated alpha again. I have given this is my phi, and already because of this phi, I got my, this is my locus example. Because of this phi, I got my alpha. Okay. Then because of this one more angle, because of this one, because of this theta, this is my locus. So it will project again. And I need to draw my one more angle, which is called as the beta. Okay. So if you see this one, already I have my line AB. I have my line AB, and I gave the inclination alpha. I gave the inclination alpha. Because of this alpha, what happens is alpha and phi. Already I gave my inclination phi. Because of this alpha, again I will generate one more inclination called beta. If I project this one point here, then I get one more final point called beta. Okay, that is called apparent angle with VP, which is nothing but the beta. So already I gave my alpha. With respect to alpha, I get my projection beta. Okay. So I'll explain once again. Listen. So this is my XY line. This is my XY line. What I done is I gave my phi. This is my actual line. Then I rotated this one. I made this phi, inclination phi, and already I gave my inclination alpha. I gave my inclination alpha. This is projected above, and for this line I made an inclination alpha. I made an inclination alpha, and wherever it is cutting the locus, from that locus again I am drawing downwards, and wherever it is cutting this locus, that point is called as the final plan length. This is called my plan length, and this is my final elevation length. Elevation is nothing but the top view length, front view length,